Hi, Mr. Andrew here, and today we're going to be talking about the quadratic standard form. So this is the classic, the ax squared plus bx plus c. We know it's a quadratic because of the x squared term, the highest power being 2, degree of the polynomial being 2. So here we're going to find the vertex, the axis, the symmetry, the x and y intercepts, and graph it. So here, beginning with that, we have to find the vertex. And let me first give you the equation we're going to be working with. We're going to be working with a simple one, x squared plus 2x minus 3. And the vertex is going to be, well, the x coordinate is negative b over 2a. That's a little formula we're going to use. That's been derived for us. And we just plug in an f of negative b over 2a, which looks really complicated, but it's not too bad. So let's first calculate this negative b over 2a. Let's say that this is b and this is a, so I have negative of a2 over 2 times a. Well, 2 times, well, there's nothing here, so it must be a 1. So overall I have negative 2 divided by 2 times 1, which is 2. Negative 2 divided by 2, which is negative 1. Okay? Now here we have to say this is our x-coordinate. So our vertex is going to be negative 1, comma, something. Well, if I had the x-coordinate to anything on my equation, I can just plug in the x-coordinate and get the y-coordinate. So I'm going to take this negative 1. I'm going to take this negative 1, plug it in. So I'm going to have f of negative 1 is equal to negative 1 squared plus 2 times the negative 1 minus 3. That's going to be 1 plus negative 2 minus 3. That would be negative 4. Sorry. Negative 4. So overall, our vertex is negative 1, negative 4. Okay? That is key. That is the vertex. So let's go ahead and place that on our graph. So on our graph, we have this right here, and we have a negative 1, negative 4. So we go down, or go left 1, and we go down 4. That's our vertex. Okay? So here, if we look further, we need to find, from where we looked at the beginning, we need to find that axis of symmetry. Okay? So if that's our vertex, our axis of symmetry has to go vertically through it. Just like this. Okay? So I know that if my vertex is negative 1, negative 4, and it's going up vertical, my axis, the symmetry, is x equals negative 1. It's that negative b over 2a. It's that negative b over 2a. X equals it. And you have to have the x equals. It is an equation, but that is the axis of symmetry. Now here, moving forward, done with that, we need to find our intercepts. So we need to find our intercepts. The easiest one, let me go ahead and rewrite the equation for us. Okay, we need intercepts. So we're going to plug in 0 for x and get our y, or we're going to plug in, replace y with 0 and find x. So f of x equals. What we're going to do is we're going to find f of 0 first, and this is going to be our y-intercept. So we have 0 squared plus 2 times 0 minus 3. Well, these are nothing. 0, 0, it's minus 3. So our y-intercept, 0, negative 3. So we can place that on the graph. So here we have 0, negative 3. This is our y-intercept. And what's really cool is because it appears here, I also know, because this is 1 away from the axis of symmetry, there should be a point right here, 1 away also. Very nice. Okay. Now here for our x-intercepts, we're going to have to plug in 0 and for y, or the f of x, and solve. So we're going to have to solve for x squared plus 2x minus 3. And there's 2 ways of doing this. One is factor, say each factor equals 0 and solve, or the quadratic formula. Now I always like to check to see if it factors first, and this one does. But if you get stuck, you have to use the quadratic formula, which at this point should be prerequisite material. So x squared plus 2x minus 3, so I'm going to have x, I'm going to have a plus 3 and a minus 1, because 3 times negative 1 is negative 3. 3 plus a negative 1 is 2. Okay? So then that's equal to 0. I set each part equals 0 and solve. And that's going to be x equals -3, x equals 1. Okay, so these are the points 1, 0, and -3, 0. So if we take those and put those on our graph, -3, 0, 1, 2, 3, and I'm sorry that I said -1, 0, but that's actually +1. Just as I write, I just misquoted myself there. So that would be a 1, 0 right there, and that looks symmetrical. In fact, it is. This is 2 spaces to the right of the axis of symmetry. This is 2 spaces to the left of the axis of symmetry. So there we go, more symmetry again. But here we're done. We basically found all our intercepts. We found our axis of symmetry. We found our vertex. So all that's left is just connect the points in a parabolic type way. And there we go. There's a parabola. If you have any questions about this form or how to solve any parts of it, just email me. Thank you.